Hello students, welcome to Memoneet. I am Swarup, teacher of Memoneet. I am here to start with a new lecture, that is our revision lecture for the electrostatics. Okay, so before I go into the questions, so I just want to remind you the formulas related to this chapter. The electric force is K Q1 into Q2 upon R square. Okay, so here the force is directly proportional to Q1 and Q2 and inversely proportional to R square. This is the Coulomb's law. Then if we have charges, that is q1 and q2 here, and another third charge, that is let's say it is the test charge, and it is placed and somewhere between the q1 and q2, and let it is placed at x distance from q1, and that will be d minus x distance from the q2. Okay, so if you want to find out the value of x here, okay, where should be the, if the question asks that where should be the third charge be placed, so that uh, it will it will be in equilibrium position. Okay, so we can write k q1 into q upon x square is equals to k q2 into q upon d minus x square. Why? This the force here for the q1 is k q1 into q upon x square. Okay, and for the force q2, that will be k q2 into q upon d minus x square. Okay, so this will be equals, if we equate this, so we have q1 upon x square is equals to q2 upon d minus x whole square. So on having the square root on both the side, we have under root of q1 upon x is equals to under root of q2 upon d minus x. So on solving this, we will get, that is x is equals to under root of q1 into d upon under root of q1 plus under root of q2. So this is the value of x. So if you find out, if you want to find out the value of q here, so just put the value of x in any of the above equation and we will get that. So this I am leaving for you. Comment, please answer me in the comment box. So what will be the value of x? Sorry, value of q here. Okay. So let's go to the electric field section. Field, electric field, we know that it is k q upon r square. That is f upon q is the formula for the electric field. Okay. So that is force per unit charge. And then electric field for an arc. Let's say we have an arc here. Okay, what will be the electric field at the O position? Okay. If it asks like that, so let's say this angle is phi by phi. Okay, this angle is phi, and we have the electric field here. This is r radius. Okay, we have the electric field, that is 2k lambda sine pi by 2 upon r. Okay, the lambda is the line charge density. This is lambda. Lambda means line charge density. It means q upon l, and sigma means, okay, sigma is surface charge density, that is q upon area. And what will be the another quantity, that is volume charge density. Okay, rho, that is equals to q upon v. Okay, so then the next formula, that is electric field for the ring elongates axis. Let's say we have ring here. Okay, and this is the axis of it, and we have the point P. This is x distance and the radius is r. So we have the formula kqx upon r square plus x square whole to the power 3 by 2. And I have taught you earlier the uh, electric field will, for the ring elongates axis will be equal in both the position. In which position? That is plus minus of r by under root 2. Okay, so this will be equal in both the position. It will find out the maximum and minimum quantity here. So then electric field for the line charge, we have, let's say we have line charge here, and the line charge density, that is lambda, and we have to find out the electric field here. Okay, electric field here. So for join the uppermost or top of the line, uh, top of the line charge, okay, to this point, and to the bottom of the line charge to this point, and the perpendicular bisector, let it be here. Okay, and it is d distance. Okay, so the theta 1 is the angle made by the this line and with the perpendicular bisector line, and the theta 2 is the angle made by the this line from where we have joined to the point P, from the point P to the bottommost position of the line charge. Okay, so this will be the theta 2. Okay, this will be the angle between these two lines. Okay. So here the formula will be k lambda upon d sine theta 1 plus sine theta 2. This we have sigma upon 2 epsilon naught 1 upon x minus 1 upon r square plus x square under root. Okay. Another, let's say we have the non-conducting non-conducting okay, non-conducting sheet. Let's say this is the non-conducting sheet. Okay, so here it is the electric field will be sigma upon 2 epsilon. Okay, then the pendulum, for the pendulum we have the pendulum that is like this. We have the time period of the pendulum that is 2 pi under root of L by G effective. So G effective can be changed in various positions. Let's say if the electric field is downwards and the G is also downward. Okay, so we have G effective, that is Z effective, that is equals to Z square, sorry, Z plus E. What is the electric field? That is F upon, that is sorry, it is Z plus acceleration. Okay. We have acceleration, that is from the F net, what we can write from the F, what we can write force due to the electric field, that is Q into E, and it must have mass, some mass. So M into A is equals to Q into E, and the value of acceleration is equals to QE upon M. So what we can write, Q E upon M. Let's say we have here another bob like this. Okay, at this position we need to find out the time period. So okay, let's say we have the electric source from here, and electric field will be in this direction, and the gravitational force will be in this direction. Okay, so the resultant will come in this direction. Okay, that is the resultant between the Z and E. So here it is QE, it is MZ. So here the Z effective will be Z square plus QE upon M square under root. Okay, as these are the two vectors and the vectors these are perpendicular to each other, so the resolution of vector will be, sorry, addition of vector will be like this. Okay, just find out the G effective in these cases and put the value here. Okay, our next is potential energy, that is U is equals to K Q1 into Q2 upon R, and potential is equals to K Q upon R, that is W upon Q, and we know that the work done by external is equals to minus of work done by conservative force. Okay, that will be equals to minus of work done by electrostatics. Electrostatics is a conservative force. Okay, so remind this one. Okay, this is most important. And the electric field versus potential in relation is equals to E is equals to minus of del B upon del R, or we can write that is V is equals to dV is equals to E dot dr. Okay, that is integration. So if we find out the value of, if we want to find out the value of electric field and potential, we can use these two formulas. Okay, so now let's come to the question section. Given that is the two charges are placed in the, as shown in the figure, where should be the third charge be placed so that it remains in rest condition. So let's say we have charges here, that is 9e is 9 electron, and this is equals to 16 electron, and we have to find out the third charge, where the third charge will be placed. Okay, let's say it is Q0. So it is X, and this will be 70 minus of X. Okay, so now if we put the equate the formula. What we will get for the 16 electron charge, the force will be in this direction, and for the 9 electron charge, let's say force will be in this direction. So this will equate so that it will remain equilibrium position. So K, sorry, it is K into 9 electron into Q naught upon x square is equals to K into 16 electron into Q naught upon 70 minus x square. From here, electron to electron cancelled out, Q naught to Q naught cancelled out, K to K cancelled out. So we have, that is 3. If we have square root on both sides, 3 upon x is equals to 4. 16 का स्क्वायर रूट क्या है 4 upon 70 minus x. So this will be 70 into 3, that is 210 minus 3x is equals to 4x. So this will be equals to 210 is equals to 7x and x is equals to 30. So from 9 electron, the value of the Q naught charge will be present at 30 centimeter. It will be 30 centimeters. So our option 1 is correct. And from the 16 electron, okay, from the charge 16e, the Q naught will be placed at 70 minus x, that is 70 minus 30, that is 40 centimeter. So these two options are correct. It means our correct answer is option 4, that is 1 and 2 both are correct. A particle A having a charge of 2 into 10 to the power minus 6 coulomb and mass of 100 gram is fixed at the bottom of the smooth inclined plane of inclination 30 degree. Where should another particle B having the mass and charge be placed on the inclined plane so that B may remain in equilibrium? So what it want to tell that we have the inclination, let's say like this, and it is of 30 degree, and a charge is placed at the bottommost position and in the incline. Okay, let's say this is A and this is B, and the charge A is 2 into 10 to the power minus 6, and charge B is also the same, that is 2 into 10 to the power minus 6 coulomb. Okay, so it is trying to ask that where should the charge B will be present. So for the charge B, if you will see, electrostatic force will be in this direction, Fe. So Fe is equals to K Q1 into Q2 upon R square. So this will be equals to K into 2 into 10 to the power minus 6 whole square upon R square. So this is the value of Fe. And another force, that is gravitational force, is also acting. Let's say gravitational force is mg here, and in this direction mg cos theta, and along the incline it will be mg sin theta. So what it is trying to tell, it is in the B charge is in equilibrium, so mg sin theta must be equals to the electrostatics force. Okay, so this is equals to mg sin theta equals to Fe. Okay, so m, that is 0.1 kg into z, that is 10 into sin theta, sin 30 is 1 upon 2, is equals to k, the value of k is 9 into 10 to the power 9 into r q square, that is 4 into 10 to the power minus 12 upon r square. Okay. So from here to 0.1 into 10, that will be equals to 1, and r square value is 9 into 4, that is 36, 36 into 2, that is 72, 72 into 10 to the power minus 3. Okay. So 72 into 10 to the power minus 3, and this will be in meter square. So if we want to find out the value in that is the value of r, that is 72 into 10 to the power minus 3 under root. So this will come nearly about, that will be equals to 27 centimeter. So it will present at 27 centimeter from the bottom. Next question here is, two identical balls each having the density rho are suspended from the common point by two insulating strings of equal length. Both the balls have equal mass and charge. In equilibrium, each string makes angle theta with the vertical. Now, the balls are immersed in a liquid. As a result, the angle theta does not change. Okay, theta will not change. The density of liquid is rho. Find the dielectric constant of the liquid. Okay, so what it wants to tell, that is it is suspended from the common point. Let's say this one is the common point. Okay, and the mass here, let's say it is having the charge q. Okay, the electric field will be in this direction. Okay, and the force will be in this direction, that is Fe. Okay, and the uh, gravitational force, that is mg, will be in this direction, and it is at angle theta. Okay. From here we can know that, that is uh, this is, if this is the tension, so this will be theta. Okay, and this will be t cos theta, and this one is t sin theta. Okay. So t sin theta upon t cos theta. So t, what will be the t sin theta equals to? Okay, t sin theta will be equal to Fe upon t cos theta. T cos theta will be equals to mc, that of mc. So t sin theta upon t cos theta equals to Fe upon mg, that is tan theta is equals to Fe upon mg. So when it is immersed in the liquid, so in the liquid, let's say this is the liquid here, and when the ball is immersed, there will be two type of force. Here the mg will act, and the buoyancy force will act in opposite direction. So we have tan theta will be equals to Fe upon mg minus b. Here tan theta is equals to Fe upon mg. What we can rho in place of m, that is rho into volume of solid into z minus buoyancy force, that is rho l into v into z. It means, sorry, sigma, the liquid density is given as sigma, so we will write sigma into v into z, sigma into volume of solid into z. Okay, so here both the theta are same, so 1 is equals to Fe upon mg, or we can write, that is in place of m we can write, that is rho into volume of solid into z, sorry, it is into z upon Fe upon rho vs z minus sigma vs z. Okay, so from here Fe is cancelled out, z is also cancelled out, and we have, that is, and volume of solid is also cancelled out. So the final answer will be rho, that is it is the rho minus sigma upon rho. One factor I missed out, when this ball is immersed in the liquid, so the permittivity will change. Okay, so the dielectric constant will also change. So in place of dielectric constant, that is we write it as epsilon naught. Okay, we will write it as epsilon naught into epsilon r. Okay, now the new dielectric constant will be epsilon naught into epsilon r. Okay, so in place of Fe, we will write Fe, we know that the force is equals to 1 upon 4 pi epsilon naught q square upon r square. So in place of epsilon naught, we will write for the liquid when it is immersed, that is epsilon naught into epsilon r. That means it will be f upon epsilon r. So this will be ap upon epsilon r. Okay. So our answer will be, this is equals to 1 upon epsilon, sorry, yes, this is equals to 1 upon epsilon r. So the epsilon r value will be rho upon rho minus sigma. So this is the answer here. Let's look to the next question, that is two identical rectangular planes sheet, that is A and B, each of surface charge density, that is epsilon naught coulomb per meter square, are placed parallel to each other. The electric field at the midpoint P will. So we know that for the surface charge for the rectangular plate, the electric field equals to sigma upon 2 epsilon. Okay. So here the for sorry A, what will be the electric field direction? The electric field direction will be in this side, and for the plate B will be in this side. And we know that the electric field will not depend upon the distance from the sheet, or okay, rectangular plane sheet. So these two forces, sorry, these two electric field will be equal to each other. So the answer will be E1 EA minus EB, which will be equals to 0, as these two electric field are equal. So answer 4 will be our answer. In this question, a thin semicircular ring of radius r has a positive charge q distributed uniformly over it. The electric field at the center O is, okay. So electric field it is asking. So we know that electric field is equals to 2k lambda sine pi by 2 upon r. Okay. So this is 2k lambda. What will be the lambda? That is linear charge density. It is q upon pi r. Okay, q upon pi r into r, that is into sine pi by 2. What is sine pi here? Pi is 180 degrees. So pi by 2 will be 90 degrees. So sine 90 degree will be 1. So 2q upon 4 pi epsilon naught pi r square. Okay, so this will be equals to 2q, sorry, it is q upon 2 pi epsilon naught square r square. So this is the value of electric field, and it will be in which direction? As this is the positive charge, it will repel. Okay, this type. Okay, it will be in downward direction. So downward direction for every single point, it will be like this. Okay, for every single point they will have in this direction, and the resultant will come in downward direction. So minus of z cap direction. So our answer is minus of q upon 2 pi epsilon naught 2 pi square epsilon naught into r square. So it is 2 pi square epsilon naught into r square. So what will be the answer? That is option C. I am doing here. I am doing the. I am collecting the regularly. I am collecting the questions from the NTA PYQs that is asked in the recent 2019 to 2024. Okay. अभी के जो रिसेंट क्वेश्चन आ रहा है तो उसके ऊपर मैं फोकस कर रहा हूँ, वो कौन सा टाइप है, और उसी को जस्ट मैं रोटेट करके आपको कुछ सवाल देता हूँ. ओके. और ये देखिए हमारा जो PYQ है, दिस इज द NTA PYQs that is published by the Memoneet, which is from 2019 to 2024 only. And how it is designed, you can see the question here. Okay, this is the question here, and you can see the Krebs solution, Krebs explanation, and the detailed explanation. Krebs explanation is for those those who commit a minor mistake. कोई आपको माइनर सा मिस्टेक हो गया, बस आपको कॉन्सेप्ट सब पता है, तो बस थोड़ा सा देख के चले जाना है, तो इसीलिए क्रिप्स एक्सप्लेनेशन इज बेस्ट फॉर यू. एंड दोज हु वांट टू हैव द डिटेल्ड व्यू ऑफ दिस क्वेश्चन, आपको वो कॉन्सेप्ट पता नहीं है या फिर कोई कंसेप्ट आप लैक कर रहे हो तो डिटेल्ड एक्सप्लेनेशन आप बहुत अच्छे तरीके से समझ सकते हो, ये बहुत काम का चीज है। ओके, और तुम ये भी देख सकते हो कि अगर हम डिटेल्ड एक्सप्लेनेशन को अच्छे से फॉलो करें ना, हमारा एक एक चैप्टर बहुत बारीकी से हो जाएगा, मतलब यू कैन complete it from the detailed explanation only. Each and every single topic you can complete and cover from the detailed explanation. So from this you can also derive uh, the questions other from these NTA PYQs. Okay, and we are coming here for the DPYQs also. आपको आपके लिए DPYQ भी हम ला रहे हैं, जो कि डेराइव्ड होगा यही PYQ से। एक क्वेश्चन से हम और कैसे क्वेश्चन फॉर्म कर सकते हैं, और दो चार कैसे क्वेश्चन फॉर्म कर सकते हैं। ओके, सो इफ यू वांट दैट बुक, प्लीज कांटेक्ट टू द मेमोनीट, वो सपोर्ट ग्रुप को आप कांटेक्ट करिए, और आपको अभी ना उसको आप प्री बुक कर सकते हैं। मतलब अभी आप हमारा कंप्लीट नहीं हुआ है, लगेगा 1-1.5 महीना लगेगा पूरा बुक को एनालाइज प्रॉपर एनालाइज करके बनाने में। सो यू कैन जस्ट प्री बुक इट, एंड ये बहुत सही काम का चीज रहेगा, क्योंकि इसी से ही हम पढ़ते थे पहले से। मैं जो तैयारी करता था तो यहीं से मैं तैयारी करता था कि हाँ, कैसे एक क्वेश्चन से दूसरा क्वेश्चन हम फॉर्म कर सकते हैं। तो दिस वन विल बी रियली ग्रेटफुल फॉर यू। क्वेश्चन देखिए, three large conducting parallel sheets are placed at a finite distance from each other as shown in the figure. Find out the electric field intensity at point A, B, C, D. Okay. So here, if we look into the question, so here for the Q charge, we have the electric field in this direction, and for the minus 2Q charge, we have electric field in this direction, and for the 3Q charge, we have electric field in this direction. So on the negative x-axis, the direction in the negative x-axis direction, we have the electric field for the Q and 3Q for point A. Okay, so we have Q upon 2 epsilon naught is the value. So Q upon 2 epsilon naught plus it is 3Q upon 2 epsilon naught minus 2Q upon 2 epsilon. So this will be for the electric field for the value for the electric for the point A. Likewise, you can calculate for the B. Let's say I am telling you B. What will be the answer of B? So for the B, the electric field for Q charge is in this direction, and for minus 2Q charge will be in this direction, and for the 3Q charge will be in this direction. So what we can write, Q upon 2 epsilon naught plus 2Q upon 2 epsilon naught minus 3Q upon 2 epsilon. This will be the electric field for point B. So likewise, you can find out the answer for the C and D. So if you if you have find out, please comment, please answer in the comment section. This we will be winding out the today's lecture. Okay, so I have completed the electric field and force portion. So in the next lecture I will be coming up with potential electric potential energy, then dipole moment, everything. Okay, in the next 2 to 3 sorry, I think we will take 2 lectures more, okay, with this electrostatics topic, and we will cover the capacitors and the rest portion that I have not covered in the theory section. I will cover now. Okay, so in the remaining 2 days we will cover everything, and please be sincere and be and study each and every portion of the electrostatics, as this is the most important part from the 12th point of view. Electrostatics, you can get 4 to 5 questions each year in the Neet. Okay, so you have to work hard, and this chapter is related to every other chapter, so please work hard in this chapter, and you can get easily comfortable in the magnetic field and then the gravitational and any other chapter. You can easily be thorough out. Okay, and according to the BTS point of view, so I just want to remind you, please buy the test series. I am working according to like that. I am teaching you like that in that process, so please buy it and have regular tests, have regular lectures. What I am posting in the Telegram channel, please do that. Okay, and attend the quizzes, do the regular task. And if you have any doubt, so please contact me in the Telegram group or in the WhatsApp support group. You can contact me anywhere. Okay, take the number and contact me. Okay, thank you. Bye bye.